This is Frahm. Frahm is Lese's approach to a particle-based spatialization system. Internally, the spatialization processing works similarly to how our other spatial positioning plugin Transfer does, but instead of controlling the target of a single sound source directly, Frahm uses a large array of different force field algorithms to change the movement of a large amount of particles indirectly. First, let's look at the visualizer on top. There are two sliders around the visualization space that allow you to control the viewing angles of the visualizer. Or alternatively, you can just click and drag on the visualizer itself to adjust the angles as well. There are also three buttons on the side, which control if we're displaying the boundaries, the center point, and the vector field display. Changing these do not affect the sound in any way. The primary functions that you will be adjusting are the force field selectors and their parameters. There is one on the left and another on the right. Clicking on the button on top opens up a drop-down, which lets you select different algorithms that can be used. We will have another video that goes over all of the available algorithms and their parameters, but for now let's just use undulate and flyby. Each of these algorithms can have up to 3 different parameters which can control either the force field calculation or adjust how the particles initially spawn. In the case of undulate, for instance, the rate control here adjusts how quickly the particles move to and from the center axis. When I adjust this size parameter, you can see how the force field visualizer changes, and how the movement of the particles also change. You can fade between algorithms by using the crossfade slider in between the two algorithm control panels here. Next up, let's look at the controls below the algorithm parameters. Density controls how likely it is that a particle will spawn after it is considered to have left the boundaries, similarly to how other granular effects work. Turning it up will reduce the time between particles leaving and returning, and turning it down will increase the time. The size controls how large the boundaries of the simulation are. This does not affect how the particles behave, but will change how far away the particles sound from the listener. The speed controls how much particles will get nudged along the axis over time. Turning it to a positive value will make it move one way, and making it go all the way to the other side will make them go the opposite direction. The max slider here changes how many particles can be rendered at once. Reducing this when there are already a lot of particles will only make it so that no more particles will spawn until there are less particles than the maximum. Moving on to the row of buttons below that. Another similarity to Transfer is the Doppler shift toggle here. This makes it so that particles will behave as if they were in the real world when we're moving relative to the listener, pitching the audio up when moving towards and going lower when moving away from the listener. The factor knob below the Doppler button adjusts how much Doppler shift is applied, if you want more or less than what is considered to be the natural amount. To the left of the Doppler toggle is the spatial mode dropdown. This just allows you to change how the particles are spatialized. Frahm offers stereo, binaural, and high-quality binaural sound. The next control is the basis adjustment, which allows you to change which axis the particles are being moved along in the particle processor. X moves them left to right, Y moves them up and down, and Z moves them forward and backward. Length and tightness controls are closely related. The length controls how large the internal audio buffer is that input audio will be added to and randomly taken from in the particle process. The tightness controls how close the delays will be to the original time. Turning it up to 100% makes it almost all the same, while turning it down to 0 will make it randomly select from anywhere in the audio buffer. You can also freeze the audio with the little button beside the length knob, making it so that no new audio is added to the buffer, so you can just play with the particle systems with whatever audio you had in it at the moment of freezing. Thank you.